Good morning, this is Cody Hendricks, and we're going to take a look at the introduction to databases, aka what the DXL. SQL, Squill, SQL, or my personal favorite, the SQL Squirrel. So there's not a real actual name that we have to worry about when we're talking about Squirrel, SQL, SQL, etc., or working with databases. I like Squirrel because it's fun, but you can use any of those different references. You'll see almost all of them. Maybe not Squill or Squirrel, but hey, I'm going to have fun with it, so we're going to call it Squirrel this year. And so we have our cute little squirrel. It's excited, it's happy, and that's what we're going to be using as our default icon for class to go along with this. So the official name is the structured query language. It started off as a structured English query language, but again, think about this. We're in a world where we're the 21st century. We are talking about multiple languages, multiple data sets, and English is not a limiter that we want to actually attach to what we're working with. We are sticking with and using lots of different data. And so structured query language is what we're happening from. This is the language that is at the heart of relational databases. This is what we do when we're talking database systems. Originally, it was developed by some papers in 1970 by Ted Codd. Now, that was a bit of a time ago, but think about this. It's only 1970. That is within the lifetime of possibly you or your parents. This is a recent development because databases did not exist prior to this point. One of the biggest things that databases are based off of is the idea of set theory. That's that specialist part of math where you're talking about how you can talk about discrete groups of things rather than contiguous chunks. And so we'll be looking at that and how we actually work with that as part of this. But set theory and relational algebra, the stuff that was invented by Ted Codd, is we're going to be doing a lot of the work with this. And what we'll be covering as part of the course and the lectures that are going along in our database series. Now, there's a lot of different flavors of databases for using relational databases. The big person on the block has got to be Oracle. Everyone knows this name. You've seen it. They've got a stadium. They've got boats, all kinds of stuff. But Oracle's the major player on stage, and they have a huge database. It's also really pricey. They have a free version, one that you can do for basically everything you want to do. And in fact, it covers everything. That's what I previously been teaching was MySQL. And MySQL is at its heart just a regular relational database system. And it can handle almost every single thing, especially for a small business, no problem. Maybe even a big business. But if you're talking about some really major scale stuff, it's not going to cover all of the needs, especially for things like concurrency and distributed systems. On the other side, we have SQL Server, Microsoft's specific mega brand thing. Now, it's also a really big, huge thing. It also is designed for on the level of enterprise level systems or large scale mega systems. And then they have their, well, not free, but their smaller itty-bitty version. And if you notice, I've got some really nasty emoji attached to this, the almost about to vomit and the actually vomiting face, because I really, really hate Access. I've had to work with it a bunch of times. It is a database, but I'd rather deal with Excel, flat files, and only straight text than work with that ever again. Then we have MariaDB, the open source version of a database system. Woohoo! Fantastic stuff. There's also Postgres, and there's actually a whole bunch more. These are some of the major players, though, when we're talking about structured query language, aka relational databases. And we'll be working with MariaDB here in class because it's a free open source version I can install with students, with high school students and work with that. But you can use the same structure and approach for all the basic Squill, Squirrel, or SQL structure on every single one of these because unless you're talking about some of the really special features inside Oracle or SQL Server, everything is the same basic structure and goes from there. We've got our major players of Oracle and SQL Server, Oracle by Oracle, the company, and SQL Server by Microsoft. They have their two little smaller versions that are designed for anything that's not quite as huge as those things. MySQL can handle everything that it can do and is available free on the internet. You also have Access, and please just don't use it. MariaDB is what we're basing off of, and MariaDB and MySQL are almost completely interchangeable, and we'll talk about that more in another time. And then you also have Postgres, which is a little bit more specialized version, and other database systems that we aren't going to be working with, but they do exist, and they follow the same basic approach. Now, DXL, in that subtitle, what the DXL? DXL is the fact that SQL, Squirrel, Squill, etc. has a little bit different structure at its heart than most of the other languages we've been working with. So we've been working with Java and Swift this year as our main languages. However, unlike Java and Swift, the subsets of the language in Squirrel are different languages themselves. And so they have a different role or language for each different type of thing you're doing with the databases. And so the functionality determines which language set you're going to be using. Now, there is a little bit of a crossover between some of those language structures, and we'll talk about that as we get a little bit closer and a little more involved with that. But in fact, most of the different types of queries or statements you'll be running inside Squirrel or SQL or SQL are going to be of one of the three different major types. So if you're talking about database designers, the people who are going to be putting together systems and designing what's going to be working with, the data sets we're going to be designing for, that is the DDL, or the data definition language. You are setting up the structures. This is like the architecture side. I'm going to decide how things are put together and what things we're going to be working with. The next step we have is the database user. Now, this can be a database user on a very intense version, like person who's actually working directly with the database, or the database user can be some casual person on the internet who's simply sending information that they don't know is actually a database query. And that is all done with a data manipulation language, or DML. And this is also sometimes referred to as some of the CRUD operations. And we'll talk more about that when we get more in detail as well. And finally, and definitely not least, is the database manager. This is the person who is in charge of making decisions not about the structure of the database, but about the who in the database. Because one of the biggest things that unfortunately has not been covered well enough, especially in previous introduction to database courses, is the idea of security. Because database security and control, as we've seen recently, if we do not have a secure and basic structured database, unfortunately that data is no longer safe and can be lost, corrupted, or worse, stolen and used incorrectly. And so we really have to take a look at how we're going to be using data and who has access and rights to data. And that's handled the data control language subset, because we really need to talk about security and privacy in data when there's now so much data that's out there. The growth of data and the amount of data that exists outside on the internet, inside networks, etc., has been so explosive. And unfortunately, the amount of attention that was paid to the security and the structure of the who has access to that data was clearly not paid enough attention to, because we now have a lot of problems and a bigger amount of responsibility to that data than previously has been assigned. And so the data control language can definitely not be ignored or set passively. We have to actually design that in advance. And so that has a definite link to these other things. And like I said, the DDL, the DML, and the DCL have a definite relationship. They're going to mix together. They definitely have roles we have to look at. And especially between the designer and the manager, we definitely have to make sure we make decisions that can make that happen. Because if the designer and the manager don't have a good correlation of information, then the database user can be malicious and cause problems, or accidental and also cause problems. And we'll see that as well. Just like we have with Java and Swift, where we have a style that we're going to be writing our code with, we have the same kind of thing. We have a different kind of style for writing SQL. And this goes back to the idea when you're writing for a different class, you have a different set of rules you're following. So when you're working with an English class, you have this set of rules for writing an essay. When you're working in a history class, you have this set of rules for writing an essay. When you're working for a science class, you have this set of rules for writing an essay. The same approach works with code. Now, we've had some basic similar structures between Java and Swift. Even though they're different languages, the same basic structures happen. However, when we're dealing over here with database land, the structures themselves are quite different. And so we're going to look at the actual style guide right here. These are the basics we're adapting from the SQL style guide. Now, these are not the overarching goals that work for everybody, but this is what we're going to be working for in class, and this is a great way to handle the main requirements we have to cover. So the first thing we have with our SQL style guide, or Squirrel style guide, is that all keywords will be in caps. Because of the fact that the Squirrel style... Because of the fact that the Squirrel keywords are all regular English words, and they're words that actually used on a regular basis in sentences, we want to make sure we differentiate them from what we're working with when we're writing the code itself. And so we'll do it all in caps because it's a very clear thing. Now, unlike other languages, Java, Swift, Python, Perl, PHP, C++, C#, Squirrel isn't case sensitive. I know, it's weird, but we'll deal with it. Now, the next thing we have in our style guide is that clauses and fields will each be separated by lines. So what this is going to do is, instead of having big, huge clumps of code like this, like we would see inside a Java or Swift or even a C++ or C# statement, where it's a single statement enclosed in a line, we'll have a keyword and then the pieces. And so it's going to be a much skinnier approach, possibly a little bit taller, but we're going to try and make it as easy to read as possible because we have so many different possible individual components to look at. And we'll do indentation to help make that a little bit easier to read. And so fields will be indented after the keyword when we're doing that. Our next thing we have in our Squirrel style guide is that table or view names will be using the plural or the collective. Now, this is going to be determining on what you're actually looking for. I personally like the plural of a thing for the table name. The official style guide that we took this from prefers the collective, but especially if you're dealing with things where the collective is also another thing. I'm going to talk about crows because a collective of crows is called a murder. But if you see a murder table in a database, you're probably thinking about something related to crime rather than biology. And so I like the idea of using collective if it works, but I think the plural is an easier association, especially for beginning database structures. The next thing we have is when we're working inside a database table itself, all field names are singular. Because a field must be atomic by its very nature, we must have our field names also be singular. Then again, because we have a no case requirement in Squirrel, we are going to be using the snake case approach rather than camel case, because when we're talking to a database, although Squirrel itself is not case sensitive, the systems it runs on are. And so when you write your database information inside a file on a Unix box, a Linux box, an OS X box or Mac box, or even a Windows box, those files are usually stored in a case-sensitive format, which actually matters, versus when running on the server for the database query, which doesn't. So we'll be using the snake case to handle that with that explicitly, because that snake case will be very easy to differentiate between regular stuff we'd see as a human being reading something and the idea of something that belongs to the database itself. Now, not quite style guide, but part of our actual style guide structure we'll be using for course is the 3NF, or third normal form, is the minimum normalization level for all databases we work with in class. This means that when you're working with databases, at the very minimum, you always have to have tables that are designed to be functional at a relational level every single time. We'll go over this on the ideas of normalization more later, but just to put this right here inside the style guide, whenever we're working in class, whenever we're doing assignments, whenever you're working with something that we're doing on these videos, the very minimum we'll be working with is the third normal form, because that makes it the easiest way to actually do what we're working with and doing actual good extractions of data and insertions of data as well. Now, the next one we have in our style guide is every single statement will end with a semicolon. Now, this is, again, one of those things that it doesn't have to be that way. If you're looking at, say, for example, the W3 Schools site, you can see that, you can just type in your scroll statement and it'll run just like that without a semicolon. However, whenever you have multiple statements run together, they have to be delimited with semicolons. So, by default, we'll just have a practice of having every statement ending with a semicolon. Finally, on our style guide, if you're not doing math-based parens, aka just like, this plus this, or this and this, or some other logical sequence where it easily, clearly matches up on a horizontal level for single-line things, any Squirrel statement where you're doing create tables or inserting or doing groups of values together, those will always require a vertical alignment of squiggles with the values indented in, because that way we can have it very easy to read and very easy for the human eye to delimit it, because that way we can make it so it's very easy to see. Let's take a look at that really quick over here. As you can see right here, we have our select statement with our parameters of first name and last name separated by line, also indented. Our from keyword, also in caps. Instructors then delimited inside. Order by the keywords together on one line, followed by the delimited parameters we'll be sorting that based off of. And of course, ending that statement with a semicolon. You can also notice right here that the dash dash in front of the 1 and the dash dash in front of the 2 indicate that those are single line comments. Just like within Java and Swift, the multi-line comment is the whack star to star whack. If you want to have a multi-line comment, we don't have to worry about them most of the time because single line comments will comment most of what we're working with. We can have that happening right here. Now, the next thing we have when we're talking about the introduction to databases is we have to find a way of designing this so that we can show it to people who aren't necessarily involved with the actual code itself. And that is where we talk about the entity relation diagram. What this is a way of designing code so it can be shown for people who aren't necessarily as familiar with the structures itself, but we can see the relationships immediately and that go along with this. This is kind of like using a UML diagram for a Java or a Swift class. And so it's exclusively for the design of databases. Each table gets a box for each entity. So table, entity, box, same basic approach right there. In the table, the left column indicates the key status. You have two different options right there, either for a primary key or a foreign key. Primary keys are what actually determine what is the thing that is determined by that, and we'll talk a lot more detail about that as we go through. Foreign keys are how you show relationships to other tables, and again, that's one of the big components of third normal form is you have foreign key relationships. Exactly one field per row, because again, we're talking about singular atomic structures, and we'll go over that in more detail as we go through it. I really want to push the idea that color is nice. We want to use colors and things that make this so it's easy to read and pleasing to the eye. We are always trying to do something that looks nice, not simply just to clear on black or clear on white, so we can actually have something like that. We want to have some color so we can use it and we can group things together and we can see a nice organization and structure simply looking at the colors as well as the content of the text itself. For showing relationships, we'll be using the crow's feet style of notation. The crow's feet style of notation has three major types. We have the one-to-one, one-to-many, and the many-to-many, which is somewhat more rare. And we'll take a look at how we can see that right here on our next example. As you can see in this ER diagram with schools players, games and cities, we can see the relationship that exists between them. We can also see the crow's feet notation with the little three things sticking out like this or like this, depending on the direction you're looking at. And for a single one, it has a single thing with a crossbar going across things indicating one thing. And we can see what those different relationships mean and talk about that more as we go into more detail on the entity relationship diagram, or ER diagram. But this is a quick little introduction to databases and how we can work with the idea of designing them in SQL or Squill, as we'll be using it for the rest of the class. Thanks again and have a great day. See you later.